Have you ever noticed a frustrating delay when your VAPI voice agent takes too long to respond? For any voice agent, the speed of its response is critical to user satisfaction, and fortunately, the speed is largely influenced by specific settings you have control over. I will show you how to optimize your VAPI assistant to communicate faster and more smoothly. I will cover key 6 elements that influence your agent's speed. The first 3 elements directly address and reduce technical latency. The remaining 3 are crucial for improving perceived speed. They make the agent feel instant even if the raw latency doesn't change. By the end of this video, you'll know exactly which parameters to adjust in your VAPI to ensure your agents sound responsive, clear, and natural. Let's begin. Before we dive into the settings, let's understand the crucial concept: real speed versus perceived speed. Latency is a technical measure. It tells you exactly how fast your server responds or the time elapsed until the voice data begins transmitting. However, the user actually experiences is based on perceived speed. This is determined by 2 main factors: how quickly they hear the voice start speaking and whether the subsequent flow of the dialogue is natural and unbroken. If we only focus on lowering technical latency, we miss a major opportunity to dramatically improve user experience. That's why we must optimize for both. The first and the most fundamental element affecting your speed is the choice of the underlying LLM. The model defines your baseline speed, as different models have different inference latencies and throughputs. You can select from a variety of providers and tiers within your VAPI setup here. Generally, models fall into 2 categories for voice agents: high capability models. These models are excellent for complex tasks like multi-step reasoning or sophisticated tool calling. I typically use models like GPT 4.1 for these workflows, as it excels at instruction following and agentic tasks. The second one is low latency models. These models are smaller, faster, and cheaper, making them ideal for simple Q&A, classification, or general conversation where minimum latency is critical. If you're building an agent that doesn't involve heavy tool calling or complex reasoning, you can significantly lower your latency by choosing a lighter, faster model. I usually use OpenAI and I set the model to GPT 4.1. Now the latency is approximately 1150 milliseconds. But if you go with lighter models like 4 cluster, I think this is the default model that's set. Now the latency is 1050 milliseconds. If you choose models like 4 mini cluster, now the latency is around 840 milliseconds, much faster than GPT 4.1. The takeaway is match the model size to the complexity of the task. Never use a large, high latency model when the smaller, faster one can handle the job. The second critical choice that directly impacts latency is your voice provider, which handles the text-to-speech synthesis. This is a component that converts the LLM's text response into audible speech. Just like with LLMs, there is a clear trade-off here: voice quality versus speed. High-quality voice providers like 11 Labs often produce the most natural and expressive speech, but this fidelity can come with a slight compromise on speed, requiring more computation time. So now the provider is set to VAPI and the current latency is 1150 milliseconds. So if I change it to 11 Labs, now the latency goes up to 1300 milliseconds. On the contrary, low latency voice providers utilize highly optimized models for speed, delivering audio much faster, but you must ensure the voice quality is still acceptable for your user experience. So for example, if I set it to Rhyme AI, now the latency is 1100 milliseconds, which is faster than VAPI. I recently shared a post on LinkedIn comparing latency across the voice providers available on VAPI using GPT 4.1 as a LLM and DeepGram Novice 3 as the transcriber. As you can see, both latency and the cost vary quite a bit depending on the provider. Ultimately, you need to balance the quality of the voice, which is a major factor in perceived customer experience. Now let's talk about the transcriber, which is the third piece of the latency puzzle. This is the engine that listens to what the user says and turns it into text for the LLM to process. Think of it as the agent's ears. If its ears are slow, agent takes longer to understand the request. and that adds a noticeable pause before the response can even start. I typically stick with DeepGram. It's set as a platform default. However, if you are an absolute speed fanatic, you can experiment. For instance, switching to a provider like Assembly AI can sometimes slightly shorten your latency. So the current latency is 1150 milliseconds. But if I change it to Assembly AI, now it's 1140 milliseconds. It's shortened by 10 milliseconds or so. Some other providers, such as certain models from ElevenLabs or Azure, are not primarily optimized for this kind of real-time conversational speed. So if you choose them, your overall latency could get noticeably slower, like 1850 milliseconds. Okay, we've finished with the settings that directly impact technical latency. Now we move on to the settings that don't change the milliseconds on your server, but dramatically improve how fast the user perceives the agent to be. The first and the most critical setting here is the Start Speaking plan. To access this, go to Advanced and scroll down a bit, and you'll see Start Speaking plan. This part essentially decides the agent's turn-taking behavior, how quickly the assistant jumps in after you stop talking. If it starts too early, it interrupts you. If it waits too long, the whole conversation feels sluggish. We use this control to fine-tune the delicate balance. Let's break down the individual settings within the plan. The first one is wait second. This is the most straightforward control. It's like a universal timer. It controls how long the AI pauses after it detects you've finished talking before it replies. So the default is 0.4. As a general rule, lower values make the agent respond faster. You can bring this down to around 0.2 seconds or even 0 if you want it to respond as quickly as possible. Even at 0, it usually doesn't feel rushed, so it's totally fine. The next, smart endpointing. This feature uses advanced AI logic to automatically determine when you have truly finished speaking, instead of just relying on timing gaps. This feature is available with LiveKit and only supports English currently. Unless you are in the specific configuration, you should keep this setting off. The next, on punctuation seconds. This sets the pause length when the user finishes a sentence that is clearly punctuated, like ending with a period, question mark, or exclamation mark. This allows for natural, expected pauses after clear, complete thoughts. If the time is too long, you get an awkward silence. If it's too short, the agent might start talking too soon, overlapping your final word. So the default is 0.1 second. Sticking to this value usually works best here, as it minimizes the dead air while still providing a fractional pause. Next, on no punctuation seconds. Sometimes the speech recognition doesn't catch punctuation, perhaps because you stopped mid-thought or were interrupted. This setting decides how long to wait when no punctuation is detected. If this pause is too short, the AI might accidentally reply while you're just taking a breath, cutting you off mid-sentence. If too short, the AI might reply mid-sentence. Default is 1.5 seconds. We can safely bring this down to 0.8 seconds. 1.5 seconds is very conservative and creates a noticeable lag. Cutting it in half significantly improves the flow. The last one is on number seconds. This controls how long the assistant waits after you say a number or a sequence of digits. This setting is crucial to prevent the agent from replying before you've finished the numerical sequence. For example, if you say, "My phone number is 604, you don't want it to reply before you finish the number. The default is 0.5 seconds, and we can bring it down to 0.3. It's often fast enough to feel responsive while still giving you a cushion to complete a phone number or an address sequence. This next element is a powerful technique to eliminate the most common source of awkward silence in complex voice agents, the tool call. When your agent decides it needs to check your database, look up some information, or execute any cushion function, execute any custom function, there is a necessary network round trip. This can be a significant pause, often ranging from 300 to 800 milliseconds, which is a huge block of frustrating dead air for the user. The solution is simple but highly effective. The agent speaks a short, masking phrase like "checking the schedule now" or "got it, 1 second." At the exact moment, it initiates the tool call. This is not a technical speed improvement, but it is the ultimate perceived speed hack. The user hears activity instead of silence, and the perceived wait time drops dramatically, even though the actual processing time is is unchanged. To set this up, you need to go into the Tools section and select the tool you want to optimize and scroll down to the Messages section here and choose Custom option and add the short conversational messages you want your agent to say while the tool is being called. Please hold on is set as default, but you can put other messages. So it says request start. This stage is the key. It happens immediately before the HTTP request leaves the VAPI platform and heads to your external tool server. By speaking at this moment, you are effectively using the agent's voice to mask the true network latency. You can optionally add messages at different stages like request complete, failed, response delayed. Finally, we get to an often overlooked factor in speed, your prompt. While the prompt doesn't affect raw connection latency, it impacts the speed of the agent's response generation. Think about it, every time your AI replies, it's processing your prompt word by word. It's like the model is thinking out loud in microseconds to structure its answer based on your instructions. Clarity means speed. When your prompt is bloated with long complex sentences or unnecessary historical context and minute details, it takes the model much longer to parse the entire block and figure out what you actually wanted to say right now. This has invisible milliseconds to the generation time. This is just like how humans respond quicker when the instructions given to them are simple and direct. Now, if you're a small or medium-sized business owner and you are curious about putting this kind of optimized voice AI to work to automate tasks like qualifying leads, handling common questions, or booking appointments, I offer a free 30 minutes consultation call to explore what's possible. You can book your free session using the link in the description below. So that's a complete breakdown of the 6 elements that control your VAPI assistant's responsiveness. We cover 3 factors for true latency reduction, choosing the right model for the task complexity, selecting a fast voice provider for quick text-to-speech delivery, optimizing the transcriber for immediate user input recognition. We cover 3 elements for faster perceived speed, fine-tuning start-speaking plan to manage turn-taking behavior, masking too cold latency with short proactive messages, streamline your prompt to make your agent respond faster and more efficiently. By mastering these settings, you can transform your voice agent from slow and frustrating into an assistant that feels snappy, natural, and truly instantaneous. If you found this helpful, please give it a like and subscribe for more tutorials. Thank you for watching and I'll see you in the next one.